So let's say that a certain teacher wanted to know if there was a significant difference between how the students, the boys and the girls in his classes were doing. You know, the difference between the boys and the girls. So he has 150, 160 students, and takes a random sample of 12 boys and 12 girls, and is going to decide he's going to compare them. So let's start with a dot plot. So the boys will be O's and the girls will be X's. And I know that this book likes you to put them on the same number line. It makes it kind of difficult to really see the shape. So I'm going to put it on a stacked number line right above and below so we can kind of see how they compare while still having them on two separate lines. So we can see there's a difference. It seems like the girls are scoring higher in general, as there's that nice big group right here of 9. These are 9 of the scores, only 3 over here. But it is skewed left, so we can see that it has that general shape of the tail. There's a tail on the left, so we know that the mean is going to be pulled to the left. The boys have more of a symmetric score, not exactly, but it's got the peak in the middle. So it's more of a symmetric, so the mean will be a good estimation of the average there, whereas down here with a skewed left, we need to rely on the median. Now, one good skill to have is to be able to estimate the mean. Now, with symmetric data, we would estimate the mean to be the median. So we go ahead and find that middle number. So it's going to be 6 from the bottom and 6 from the top. 1, 2, 3, 4, 5, 6. So it's going to be these two right here. And obviously, that's going to be 87. So we should expect our mean to be 87. Whereas for the girls, we know that the mean is going to be pulled to the left of the median. 1, 2, 3, 4, 5. So the middle two are right here. So that's 6 from the top and 6 from the bottom. Since I know the mean is being pulled to the left, I'm going to go ahead and estimate 87 as well, because I know it's to the left of 90. Maybe 87 is a little low, maybe more like 88. But I wanted to estimate the mean based on the shape. So again, I know because it's skewed data, it's going to be slightly to the left, whereas with symmetric data, it should be right where about the mean, or the median and the mean will be about the same place. So now let's go ahead and find the actual means so we can see how close we got. And we can see we were close, but not exact. The boys were a little bit lower than 87, 0.25 lower. So even though we estimated 87, it came out to be exactly 86.25, so a little bit lower. And the girls, like I said, a little bit higher than the 87. Like I said, maybe more around 88, and it was closer, 88.25. But you can see that it was pulled toward the tail for the girls here. So according to our means, the girls are doing slightly better. In fact, it looks like 2% better according to these samples. Something we didn't talk about yet is that the medians, we did find the medians going 6 from the top and 6 from the bottom. The boys' median score is 87. The girls' median score is 90. So according to the median scores, the girls are doing 3% better, 2% better according to their means. The next thing we want to do is create a box and whisker plot. So we're going to get rid of some of this. But one suggestion I make is before we get rid of these, because we're going to need this area, is that you use these. See, these are in order now. And in order to find our 5-number summary, you need to write the numbers in order from least to greatest. See, we've got 78 and then 81 and 84 and 84 and 84. And then down here the girls as well. Maybe on a separate piece of paper, write them down in order from least to greatest. And with little pieces of data, 6 from the top and 6 from the bottom will give us our median. 1, 2, 3, 4, 5. 6 from the bottom. 1, 2, 3, 4, 5. 6 from the top. So For the boys, this is our median. Now we don't really have to add them up and divide by 2 because it's 87. So this is our median, 87. So remember, with two middle numbers, we split them in half and count the one on the right with the top half. So there are 6 left. So 3 from the bottom and 3 from the top. And since there are 2, we need to add them and divide by 2, which gives us 88.5, and that's our third quartile. And of course, our maximum is at the very top, and our minimum is at the very bottom. And third from the bottom and third from the top of the bottom half. And we don't have to add them and divide by 2, but that is our first quartile. So we're going to take these 5 points and create a box and whisker. So we can see our number line down here on the left. So at 78 we put a dot. At 84 we put a dot. 87. 88.5, which is really close, and then 96. And then you create a box with the first quartile and the third quartile. You put a line at the median, and then you connect the minimum and maximum. And this is to show how spread out each quarter of the data are. So this is 25% of the data, this is 25%, this is 25%, and this is 25%. Sometimes students get confused and think that there are fewer numbers here than here, because here it's longer than it is here, and with a smaller area it looks like there's less there. There's not. It's just that it's more compact, and this is more spread out. And the box, remember, is the middle 50% of the data. Now let's go get the same numbers from the girls. Maybe we'll use a different color to make it a little bit easier to see. So the middle two, 1, 2, 3, 4, 5, 6 from the bottom and 6 from the top. This is our median. And again, two middle numbers, we split them in half. So 1, 2, 3 from the bottom and 1, 2, 3 from the top. This is our third quartile. And our max and our minimum. 1, 2, 3 from the top and bottom, and I need to average that to get 85.5, and that's our first quartile. So for the girls, we're starting out at 78. That's the same. Then 85.5, 90, 93. Ooh, and 93. Is that a problem? Notice that our maximum and our third quartile are the same. Well, it's just going to be a little bit funkier looking box and whisker. It's only going to have one whisker. So we make a box with the first and the third quartile, and we connect the minimum. So when we don't see the other one, we understand that the top 25% is all the same number. So here's the first 25%, the second 25%, the third 25%, and the fourth 25% is so compact that it's the same number as the third quartile. And this is our middle 50% right here. Now you can see that the girls' middle 50% is more spread out than the boys' middle 50%. Again, all a box and whisker plot shows you is the spread of the data, each quarter of the data, how spread out they are. And it simply shows that the boys has less variability, the girls has more variability in the interquartile range. Other than that, you can see that the median for the girls is higher than the median for the boys, that the boys' maximum is higher than the girls' maximum, and that their minimums are equal. But the interquartile range for the boys is slightly lower than for the girls, even though it's a shorter box, meaning it's not as spread out. Looking at our box and whiskers, the boys, this box and whisker still supports the fact that the distribution is symmetric, whereas this one, obviously having a whisker on the left and no whisker on the right, suggests that it is skewed left as well.